Hello, Algebra 2. In this video, we're going to be working on solving quadratic inequalities. So that means things are going to have symbols like greater than, less than, greater than or equal to, or less than or equal to. Here we go. Your book gives you this table to kind of summarize some things about quadratic inequalities. The most important thing are these three steps right here. First, you're going to graph the parabola. So just like normal, graph whatever function that is. Don't worry about the symbol there yet. Then in number 2, you're going to use a solid line if it's less than or equal to or greater than or equal to. So essentially the solid line means that we want to include what's on that line. And you're going to use a dashed line if it's just less than or greater than symbols. And then lastly, you're going to shade above the parabola if your symbol is greater than or equal to, and you're going to shade below the parabola for less than or equal to. So far in this problem, I've found the axis of symmetry to be 3.5. That's my dotted line right there. I plugged in 3.5 into my function and evaluated that to get negative 2.25. And so my axis is going to be at the point 3.5 comma negative 2.25. So that's it right there. And then the y-intercept is positive 10. So I put that point in right there. I reflected that point to get one more. And then we now know how to solve quadratics, so let's find the zeros to get a few more points that we can graph. So I'm going to do this by factoring. And so I'll put x and x, and I'm going to use minus 5 and x minus 2. If I multiply all that out, I would see that I would get negative 7x in my middle term and a positive 10 on the end. And so my zeros would be x equals positive 5, because that's what makes this term 0 if I plug it in, and x equals positive 2. So I'm going to put those points on my graph. There's x equals positive 2, and here's x equals positive 5. It's a good sign that they are reflected across that axis of symmetry. So there's my graph. Now to actually graph the inequality, we are looking at our inequality symbol right there. It is a greater than or equal to sign, so we were right to make this a solid line because of the equal to part. And it is greater than or equal to, so we want to shade everything above the line. So that would be this area right there. And what the shading tells us is that all of the points in this area would make the inequality true if you plugged in the y value and the x value for any point in here. This is the same graph that we just created, and it's good practice to choose a test point to verify our solution. So let's choose something easy. I'm going to choose 1, 5, because remember our solutions were in this area. So pick a point that's in that area, plug in your values for x and y, and just make sure that it makes it true. So I'm going to plug in 5 for y, and I'm going to plug in 1 for x. And when I do that and evaluate it, I'm going to see that it is true, or I end up with a true statement that 5 is greater than or equal to 4. So that's telling me that this area that we shaded in was the correct area. Okay, here I found the axis of symmetry, I found the vertex, I found the y-intercept, and then I reflected that point across my axis of symmetry. I can see that my graph is going to open downward, which makes sense because this is negative out front. So I don't really need to find any zeros because my graph is not going to cross the x-axis. As I graph this, I do notice that it's just y is less than, so it's going to be a dotted line, not a solid line, because we don't want to include the points on the line here because it's just less than. And since it's less than, I'm going to be shading inside or underneath the parabola, so there it is. To make sure that I did this correctly, I picked a test point, -1, -6. It is in my range that I have shaded. And so I'm plugging in -6 for y, -1 for x, and I'm just evaluating to see if this ends up to be a true statement. So I've started simplifying. As I keep simplifying here, I'm hoping to see that -6 is indeed less than what I get on the right-hand side, and it's less than -4, so I know that I graphed it correctly. In the next equation here, we don't have any y's. We just have x squared plus 8x plus 20 is greater than or equal to 5. So we want to know what do the x values need to be to make this function right here greater than or equal to 5. So I would suggest using Desmos for this. You can graph them by hand if you want. If you just type in the inequality that they give you though, let's look at that real quick. If you just type that in, I turned it on my graph, you get this really weird looking thing like this, right? So you can maybe interpret what's going on here, but it doesn't look like any quadratic that we've seen. So if you just graph the quadratic part right here without the greater than or equal to 5, and then I'm going to graph y equals 5 so that I can see what's going on here. Then you notice that everything right here has y values greater than 5, and everything right here has y values greater than 5. So these points right here become really important. And so we see this at the point -5, 5, and the point -3, 5. And remember, these are x and y. And so what we're seeing is that if x is less than or equal to -5, then my y value is greater than 5. And if my x value is greater than or equal to -3 going this way, then my y value is greater than or equal to 5. And so my answers on this would be that x is going to be less than or equal to -5, and x is going to be greater than or equal to -3, because when that happens, my y values are greater than 5. Okay, so in this one we have the same function, but now we want to know when is it less than 5. So I've graphed my function, I've graphed the line y equals 5. I can see that right here is where my function ends up being less than 5. So again, these 2 points right here are really important. So if x is anywhere between -5 and -3, then my function is going to be less than 5. Now it's just less than, it's not less than or equal. So I would write the answer for this as x is going to be between -5 and -3, and just using the less than symbol, not less than or equal to, because we don't want to include those, because we want it to just be less than 5. So these points we've been finding where our quadratic and our line that we're looking at to if something is greater than or less than that, where they cross is called the critical values. And by finding these, we can solve quadratic inequalities algebraically, that means without graphing. So to solve this type of inequality algebraically, that means without graphing, I'm first going to write it with an equal sign. And now we're going to solve it just like we would any other inequality. So I'm going to set it equal to 0 first, and then I'm going to factor. And in this case, I would have x minus 3 and x minus 7. So my values are at x equals 3 and x equals 7. These are going to be my critical values now, and I'm going to put them on a number line to make it a little bit easier for myself. And now you split your number line into 3 parts, and we're just going to pick a number from each section and test it out. So I'm going to test out 0, because that's usually an easy one. I'm going to test out 5, and I'll test out 10. And so first, testing out 0, I would plug in 0 to my original equation, and I would see, does this make the equation true? So when I evaluate this, I would end up with 18 is less than or equal to -3. That is not a true statement, so this one does not work. When I tested them out, I saw that 5 does make a true statement. I would end up with -7 is less than or equal to -3. That's true. When I test out 10, I get something that is not true. And so this then is my range where my values lie. And so I could write my answer as x can be anything between 3 and 7. Okay, so I have graphed this function right here in Desmos, and then I've also graphed the line for 7,500 right here. And it says that this trip will be rescheduled if the profit is less than 7,500. So that's this part right here. And so how many people have signed up? Well, less than going this way. This X value is 13.82. So if there were less than or equal to 13 people signed up, because we have to have whole numbers for people, or over here, if there were greater than or equal to 37 people signed up, then the trip would be rescheduled.